everybody, and welcome back to another amazing episode of the Little Horse Tech Talks. And today I'm going to do a very beautiful live stream with one of our technical experts in our team. And we're going to talk about an amazing topic, which is the transactional outbox. So before we go do that, let's introduce our new guest, and he's going to be Mijaíl Rondón from our very own LittleHorse technical team, and he's an expert in Terraform and JavaScript. He's working on various infrastructure and front-end initiatives for LittleHorse, and we're very excited to have him on team because he's built amazing stuff for us. So let us invite him over, and then we're going to have a lot of amazing talk together. Hi, Mijaíl. How are you doing?
Hi, everyone. I'm doing fine. Hi, Sahini. Thanks for
Hello.
this invitation.
Yes. So we're going to have a lot of fun today because we're going to cover amazing areas around transactional outbox, and we're going to talk about why we're talking about transactional outbox with LittleHorse today. So before we go diving deep with all of that content, I have a very important request to our audience. If you're watching us live right now, do not forget to come drop us a hi on the comment section, and we're all here to answer your questions. While we're mindful of our time, in case we miss any of your questions, we're going to come back to the comments and answer back to your questions. All right. So when we talk about transactional outbox, my first question goes to you, Mijaíl. Why are we talking about transactional outbox today?
Well, transactional outbox is a common pattern that is being used for microservices. This tends to solve a common problem, which is when you try to write a transaction into two different systems. So this is basically what we want to talk today.
Okay, so when you say transactions in two different systems, like I'm very curious, what are these transactions that we're talking about? Like if you could just give us a tiny little, very basic and lame example of what these transactions actually mean.
So, well, sometimes you to give a specific example, in an e-commerce platform, you could have one system that is in charge of getting the payment, while another system is handling the warehouse. So in those scenarios, you will sometimes you will need the payment system to notify or to create an event that the payment was successful, while the warehouse is waiting for that event to commit the shipping, right? So in that specific example, you will need that the system is atomic and it commits the transactions at the same time, because you don't want to have data losses, or if, for example, the warehouse fails, what would happen with the payment transaction? So you will need
Right.
to roll back it. So that's a problem that it solves. How it solve it, we can talk about it if you want.
Okay, yes, we can. But before that, as far as I know, and with all the knowledge that I've gathered together, from research and the works that I've done, I believe that transactional outbox pattern requires quite an extensive setup. Is that correct? Like, having an additional database table, dual writes within a transaction, and then a complex, change data capture, CDC, something like Debezium and Kafka Connect, right?
Yeah, it's true. Well, there's different ways to solve it, but the pattern suggests to use a database which will
Okay.
store like like your email, right? So the payment system will like send a message, or store this message on a database to keep track
Mm-hmm.
of the things that it already stored and hasn't been sent to the warehouse yet. And then should be another system that reads this database, or this
Right.
message here, that and then process or sends a message into Kafka, or through another broker or something.
Got it. Okay. Yeah, that makes sense. But yeah, so like if you were to explain briefly, because our audience is a mix. We've got audience who are who are intermediate, we're advanced, and then we've also got basic people who just want to learn about what this thing is about. So like if you were to briefly explain what a transactional outbox is, like this microservice pattern, what would you say, like what this is?
So, well, it is basically so as I said, this stores, so the system that originates the transaction needs to commit something into database, and then another, and then the same system in the same transaction, it will add this queue into another database owned by the same system. So it should be in the same database because um, you want to wrap it in a transaction. So if for some reason one of the two writes fails, it will roll back the transaction. So that's how it works in the originating system. Then on the target system, it will um, you could have um, a cron job that is reading this outbox table, and then it produces a Kafka message, for example. Um,
Okay.
and
Mm-hmm.
this Kafka message is then consumed by another system um, that will trigger the event on the warehouse system. And that's how it works.
Okay. Got it. That's quite interesting. But I would love to learn how we at LittleHorse solve this problem of transactional outbox pattern. Because you would know it more nicely because you have done a very nice demo on it. And I think I did a video about it, but I would like to hear from you about how does LittleHorse solve this problem.
Yeah, one thing that's cool about LittleHorse is how easy it is to solve this problem.
Mm-hmm.
Because you don't need to rely on anything um, besides LittleHorse itself. So you get out of the box error handlings, the coordination between the microservices, what goes first, what goes after, and even UI events. So you could generate specific events on the UI, so the user get immediate feedback. Um, so that's the demo that we made. It was a oversimplified implementation because we wanted to show briefly the capacities or capabilities that um, LeaderHorse has without overwhelming about the technical details or the technical complexity of a system like that one.
Right.
So what LeaderHorse does is so we have workflows, and these
Mhm.
workflows is like the architecture um of our service, right? Or
Right.
so LeaderHorse define how and when and in which order um uh things must be executed.
Right.
Uh, so I don't know if I can share my screen. Like,
Yes, please. I will. Yeah, you can share your screen and we can quickly do something. Maybe you could show us a demo. That would be amazing because we're all excited to hear about a practical use case. That would be awesome. Absolutely. So if you
cool,
could show us something, it'd give us a little bit of more heads up on what we're solving.
cool.
Okay. So I have added it to the stage and probably
Yeah. So this
okay.
this is what I was talking about. So um
Hmm.
this is the transactional outbox in a traditional system. So as you can see, you have an order system, and
Right.
this has a database. And every
Mm-hmm.
time that it needs to commit a transaction, it it could be an insert, a update, or a delete. It
Right.
inserts something in that table, and in the same transaction, it will insert this outbox table or
Mm-hmm.
outbox entry. And then we have a message relay that could be a cron job or something that is
Right.
reading from that table and generates a message. After that, as I said, there will be another system reading from that event, or well, doing something regarding this event.
Mm-hmm.
In this example, will be the warehouse will be subscribed to this message to do something. On LittleHorse, as we use workflows, or we define things with workflows,
Yeah.
you will see that we have something that is BPM and like graph. So you can see here we have process payment, which is a task. Then we have ship item, which is
Mm-hmm.
another task that goes after the previous one. And we have here this bolt that um, it represents an error handling. So if something goes wrong with with ship item, then it will issue a refund. So that is this is how the demo file looks like. The demo architectures looks like. So we have
Mm-hmm.
an UI and we have a notification system, which is basically a supporting system for the UI. This is just to show notifications on real time on the UI. And then we have the two systems, the payment system and the warehouse system. Um, so in the payment system, we have these workers. On LittleHorse, we have the concept. So each task is attached to a worker, and then um, on code, I will show the code later. On code, we define which with our DSL, we define which worker is running which task. So in this case, the payment system has two workers. The one is for the process payment, and the other one for to issue the refund. And it
Right.
has a database that is storing all the transactions, right? Um, so as you can see, there is no direct connection to to the warehouse because everything happens through the workers. So
Mm-hmm.
then in the warehouse we have a ship item worker, and it owns database. So yeah, that's the architecture of this specific application. As you can see, is
Yeah.
is simpler because we don't have anything connecting between these two systems, and they are just relying on the little horse to to coordinate the transactions between them.
Got it. Yeah. I think this looks really good, and this includes like spinning up several microservices, and each of them have a very critical role in our transactional system. That is what I understand. Because these services interact seamlessly with each other. And all thanks goes to Little Horse and the magic behind it. So from what I can understand is that when a payment is initiated, the process payment service takes over, and it's followed by the ship item. And if necessary, the issue refund is also initiated. So it's kind of a streamlined process, but behind the scenes, there's a lot going on. Am I correct?
Yeah, there's a lot going on little horse. Yeah.
Yeah, yeah. I'm sorry for the noise because my cooker's whistling. I'm sorry if that sounds terrible. Okay. All right. Cool. So now can you also show us like a real demo of this? Because I know you built something cool to depict the transactional outbox pattern, some kind of code and some kind of, cool application that you can show off to us. It would be amazing.
Sure. Let me share my entire screen so it's easier to see.
Absolutely. Let me know when you'd like to share the screen. I'll pull it up.
Okay, I think we can share now.
Okay. Here you go.
So this is the repository where we store all our examples. Is is called LH example. Is in our GitHub. And here you can see on the root level, you can see the transactional outbox example. If you follow the README, let me open in.
Yeah. Mm-hmm.
Uh, this, I forgot how to.
It's okay. Take
Well,
your
it's
time.
okay.
There's all the time. Yeah.
Okay, so in the README, you can see like a pretty easy step by step how to run this example. So you'll
Right.
see we're using Docker Compose to simplify the deployment. So this is deployment LittleHorse server with all its dependencies. This is LH standalone. Then we have the warehouse system, which is an API and and as it's shared is two workers. Sorry, one worker. Um,
Right.
the warehouse database, which stores all the transaction of this one, and then the payments system, which also has a database, and the commerce, which is the UI and notifications supportive real-time notifications on the
Okay.
UI. So we use this HTTP request just to set up like the initial data. So in this one, we want to credit a gift card with 130 virtual currencies. So let's
Yes.
send this one.
Mm-hmm.
So this is already created. You can see here there's a idempotency key. This is a core concept on LittleHorse.
Okay.
This is to identify that something has run well to make sure that this transaction happens just once.
Okay.
We can go deeply into this detail in another conversation, but because it's very interesting.
Okay.
Um, then I want to see what's the current balance of this one. So if I send this, you can see I'm still 130.
Mm-hmm.
Then I want to create cookies in the warehouse. And that's it. And let's see the cookies balance.
Okay.
Cool. So now if we follow the README, you'll see then after that you could go to this web page. Let
Okay.
me copy this. Oh, sorry.
Yeah, it's okay. Just yeah.
I'm on Linux right now, so I'm used to use
I still
macOS.
don't understand like how people fall in love with Linux. I'm still trying to like all that I understand is Mac is great, but I still can't understand how I can ever shift to some other operating system. But okay. God.
Cool. So now we can see our
Yeah.
UI.
UI. Mm-hmm.
So you can see here we have cookies. So let's see
Right.
cookies. So as I show in here,
Mm-hmm.
we have a balance of 20 cookies.
Okay.
That's the same that is being shown here. So
Right.
if I try to use our gift 130
Mm-hmm.
and I want to buy just one. So once I click this, um, the UI system, this UI will trigger a workflow run. Um, and this workflow run will execute the task. So let's run this.
Mm-hmm.
And you can see
Oh,
immediately you see
we have yeah, one
from
cookie
top to
wish.
from bottom to
Yes.
top, the payment happened first. So
Mm-hmm.
we should this amount
Right.
debit, and then we
Mm-hmm.
shipped. And we see here there is just 19 in stock now because here. well, we got one. So
Yeah.
we can repeat this transaction as many times as we want, and we will see that the balance and the stock will be reducing sequentially, right?
Right.
So if we go to the API again, just to see the
Mm-hmm.
balances, we'll see. Let's run this one. Oh, I created 20 more. Sorry, but yeah, there are 34 now,
Mm-hmm.
and our account balance is 103 with something.
Okay.
So now let's buy 10
Okay. We'll buy them all
and 10
because we had
more
some existing. Yeah.
and 10 more. So
Oh,
there's
it's balance.
no balance. So what happened?
Okay.
Let's go to
Mm-hmm.
here. You will see that the account balance is just 13. Um, and so we're not getting the payment, so the transaction holds, right?
Yes. So here,
So
I would like to ask, like, is does this come under a technical error, like network failure, server crash, or system level issues, or something unpredictable and that is not related to business logic? Is this something that comes under that?
well, this is specifically is a business error, so it's
Okay.
expected. So we know that the user may not have enough balance. So
Right.
this is a business exception.
Mm-hmm.
Um, so we just treat it like as a failure, and
Okay.
we hold the and we finish the workflow run.
Mm-hmm.
Um, then if the case is different, so let me show you the case where um we have
Yeah.
enough balance. Let me send this again. So we have
And while you do that, I just want to tell our users that here's something that we all can note that in LittleHorse, we distinguish between technical errors and business exceptions to maintain transactional integrity and a smooth user experience. So this situation and this error that you saw is an exact example of a business exception. So this could be something when a user doesn't have sufficient balance, which leads to a credit card decline or items being out of stock. These are all part of the expected workflow of any transactional system. Am I right, Mijail?
yeah, correct.
Okay, cool.
So okay, so now I have enough balance.
Mm-hmm.
Let me buy 10 more. So it will
Ship
be
it.
good. And then
Yes.
four in stock.
Or
So
in
what would
stock.
happen?
Right.
So we
In
see
stock.
in time we
Yeah.
see that we receive the payment,
Mm-hmm.
but then we notice that so the warehouse system um
Right.
returns an exception because this
Mm-hmm.
is also a business exception. There's no stock on on the
Mm.
warehouse.
Right.
So
Right.
what it does is um to notify, well, LittleHorse when it runs the task. So in fact, let me show you the code of that specific part. So let's go to ledger src, and this is the worker for warehouse. Oh no, this is the task. Sorry, task for warehouse. So let me open this. Okay. So in this implementation, well, there's some annotations. This is Java
Mm-hmm.
specific annotation for our DSL. So this is
Okay.
how um, when you compare this application, LittleHorse know which one is a task, right?
Mm-hmm.
Which thread is a task. So in here we you see that we try to debit that amount
Right. Yeah.
uh, well to debit that amount of SQs And if there's exception, in this case, we're handling the exception with JPA, because it's a
Mm-hmm.
database issue. We're storing the logic of determining if there's enough balance or not in the database. So that's why
Right.
we could throw two different exceptions. One is um, out of stock, which is the specific one that we're seeing right now. So you can
Right.
see this is defining a name, and this name is referenced on the workflow. So
Mm-hmm.
when we handle this exception, we look for this specific exception out of stock, and then based on that exception, then we execute a follow up task, which is issue refund. So
Mm.
what issue refund does, and if we go to the implementation, um, this simply search for a specific ID of the previous transaction, and then it simply reverts and
Okay.
um, like removes from in this case removed from the database
Mm-hmm.
the, the previous transaction.
Okay.
Um, okay, so and this is the message that the user receives. Yeah, and that's pretty much it.
Okay. Yeah, so I think we covered three scenarios and situations out of this, and some of it was business errors, and some of it like business exceptions and technical exceptions, and some of it was a successful transaction. So, from what I could understand, is that like under the hood, LittleHorse performs all the heavy lifting to make this transactional outbox pattern accessible. So there is no extra tables, no dual writes, or no direct CDC management, and no need for ancillary stream processing. So if I were to understand this, I would say that in conclusion, LittleHorse presents a potent method to harness this kind of transactional outbox pattern without its customary complexity. So what I would say to all our developers and enterprises alike for watching us today, this translates to more time devoted to value creation rather than infrastructure management. So yeah, I think this was a very great example that you shared with us, Mijaíl, and kudos to you for building this for us. Because sometimes what I feel is when you have an actual demo or you have an actual example, it makes concepts more clear for people to understand whether someone's here to learn or someone's here to understand what is LittleHorse doing with transactional outbox, or someone's trying to understand what's new happening, right? So I think this was quite amazing, and I could gain a lot from this, and I also believe that our audience might have gained a lot from it. And yeah, I believe that we'll be able to answer all your questions. So yeah, thanks Mijaíl for this awesome demo and all the insights that you've shared with us today. It was amazing to hear and gain from you. I hope you enjoyed too.
Yeah,
So we're gonna, yeah, absolutely. Cool. So I think we're by the end of the hour, and we're gonna say bye to you all. And we're gonna come back with a new session soon. We're gonna come back with a new episode soon with something more exciting, some more demos and examples. It's gonna give you a lot of amazing insights about LittleHorse. All that we want from you is to stay tuned and do join our community Slack channel to learn more. Once again, thank you everybody for joining us. Thank you, Mijaíl, and we're going to see you soon. Bye,
thanks.
y'all.
Bye.
Bye.